Hi, my name is Jacqueline Meier, Assistant Professor of Anthropology, and today I'm going to be telling you about my DHI project, which was to explore Shiny tools for R. R is a programming language for statistical analysis, and it produces striking data visualizations. R consists of a series of what are called packages, which are collections of different functions and data and other information, just as it sounds, all packaged together. And for my field of anthropology, there are many examples of packages that are quite useful for anthropological analysis. In my field of zooarchaeology, the study of animal remains from archaeological sites, there's a very useful package called ZooLog, which lets you compare measurements of animal bones to those of a standard animal. For cultural anthropology, there's a package called AnthroTools, which lets you concisely study consensus data that's taken from free word association surveys. R is free. You can download it from what's called the CRAN, or the Comprehensive R Archive Network. And the easiest way to use it is through RStudio, which is a developer environment that lets you work out scripting your code and running it in a console all in one easy way. Now, through my exploration of looking for an easy way to jump head into R, the best book I found for the social sciences is what's a book that's called R for Data Science. When I was going through it, I was looking through exactly how our scripting works for analysis across the social sciences, which is quite broad. And it's kind of a daunting task to perform analysis in R. That was my first conclusion I came up with. You can see here what the R platform looks like. It's not all that user-friendly, and I'd say it's exceptionally not student-friendly. You run your script in one corner of it, a console runs in another. An environment is off to the side to tell you which packages you've loaded, and then your actual results are in the graphical output window that you can see in the bottom right. Um, there are other challenges to using these statistical programs in the archaeology classroom, but the challenges, I believe, are worth it. In zooarchaeology and more broadly in archaeology, um, per performing scientific analysis that's reproducible is key. And scripting the types of analyses that you run allow that to be possible. We also work with complex data sets, these different multi-tiered types of data are ones that more and more zooarchaeologists are posting online, making them openly accessible when we produce our articles and books. And so if we have the tools to share our analysis and share our data more freely now than we ever have before, being able to reproduce the analyses that are built up to our results and our conclusions is also key. And so this is a key skill for students to build up going forward, is being able to analyze, not only produce these complex data sets, but analyze them and share them with others in a way that they also can come to the same results or test one's results. This is a very important skill set for future archaeologists. Now, it can be quite difficult to teach statistics to undergraduates, and one of the main challenges with this is because statistical programs have a high price tag. We have subscribed to several here at UNF, but students only have them for the duration of our classes and don't have access to them after graduation unless they pay for them or their job pays for them. And so one of the benefits of using R is that it's free. There is a coding and a scripting learning curve, though, that can be quite hard to overcome. It is worth it, though, because the flexibility of the results and the styles not only looks good, but it also allows the user to decide the most informative way of grouping their data to compare it or to analyze it. So you can see here the differences in different types of histograms that can be produced for archaeological data in R. So you can have a basic histogram of length. These are binned into some quite broad categories, though. You can ask R or change your script slightly to make those bins a little bit more narrow to show more detailed histogram data. Now, one way to use R where you're not directly manipulating the code is through a new AI tool that's called Shiny Assistant. Let's take a look at that. This was the tool that I focused on most for my DHI project. All right, this is the home page for Shiny Assistant. Shiny Assistant has this nice handy landing page where It very quickly walks you through what this AI tool can do to help you to build what are called Shinies for R. Shinies are essentially just apps that run our script, and Shiny Assistant helps you to write the code to run those apps. So here you can see the example on the home page, which shows you somebody's asking Shiny Assistant, create an application which calculates mortgage payments. The AI scripter makes the R code, and this leads to this app you can see here that performs the basic function requested. Now, Shiny Assistant can be used in quite a few different ways. So here I've got some examples of how I've tried to build Shinies for R that I can use with archaeological data. So here you can see I typed in, can you make me a Shiny app to compare the lengths and widths of bones to look for patterns in those measurements? All right, so it replied to me, I'll create a Shiny app for comparing bone measurements to identify patterns. This app will allow users to upload their bone measurement data, visualize relationships between length and width, and analyze potential patterns using various plotting and statistical methods. All right, so it's written me this nice script. It then, once the script is done writing, it moves it over to my mini version of RStudio. It then will run that script through the console and produce my Shiny app like you can see here. And so I can have it rerun the script here for you. My app is starting, and here it is. So without even asking it to, it's made some test data, some mock data that I can use to test out the app, which is really nice. This also allows the user, student or faculty, to figure out whether the app is working and whether it would work with the kind of data that they're trying to build an app to for analysis for. So you can see here, I'm using just the sample data. I also could upload a CSV file with different types of bone data organized by the type of bone and length and width measurements. It looks like here it has given me some different ways I could visualize this data. Here we've got a scatter plot with a regression line running through it. You can take that off or leave it on. Got a little margin of error too. And I could also look at it as a box plot. It's nicely color coordinated, my different types of bones, also without me asking it to. Remember, I just asked it to make an app that could compare different measurements of bones. I can use a correlation matrix or even a 3D scatter plot. Here it looks like it's going to add in a third variable, which is density. All right, so all I asked it again to do was make a Shiny app to compare the lengths and widths of bones and look for patterns. And it has found that these different ways that I can do this for me, that it can do this for me with different kinds of bones and different measurements. Now, let's say that I have some data that I would like to make an app to analyze. A common type of data that we use in my class is burning data from bones that come from different contexts of sites. So this is some data. You can see these different contexts here. These are, some of them are it's basically one numbered sample versus all of the others. And they're categorized by how burned they each are, and by counts of bones that are burned to that degree for this site. So I know that the best type of analysis I can do for this is a chi-square analysis. I know that from practice. And so what I would like to do is ask my Shiny tool. I'll ask it, can you build a Shiny to conduct a chi-square test of similarity on the following data? All right, and there's my data. I've just cut and pasted it from Excel there. All right, it's running my script. You can see it loading in down here. All right, I fast forwarded a little bit. I can show you what this looks like after it's finished building my entire app here, giving me some script. I've actually refined that a little bit down here because the visualization wasn't showing up quite right. So I said, can you adjust the visible windows for easier use? And it adjusted the script to do that. And so if I move over here to my evidence here, it's got my data plotted out quite nicely. The data itself is reproduced here in this data table. It's Got the results of my chi-square test here of independence and an interpretation even of what that p-value might show. I'll just give you one more example of how I used Shiny Assistant to build another app. This one was for my zooarchaeology methods class that I'm teaching this semester, so I'll be using this next semester. And it's to run a very common type of test that we do, which is one of biodiversity. And so I've got some data in a CSV file that I'd like to upload here. It's reading my data set quite quickly. It's got each of the contexts from my site on this in this column here, and then counts of different kinds of fish that we've identified from this archaeological site, which is very interesting. Now, what I can do is run, I only want to run one at a time, run some different diversity indices. I'll do a Simpson's index, Shannon's index just to start off with. Would I like to include refraction analysis and extra permutations? Absolutely. So I'll run this test. I'll go over to my diversity indices. Oh, that's quite beautiful. It's making me a nice histogram here, even though I didn't ask it to. It's plotting out my data for me. Here are my Shannon index results. And again, it has plotted out. It's got this nice tool where I can hover over and actually see what the values of each of these are. If I go over just to the basic species abundance tab, I can see a kind of a messy but usable bar plot here. Or I can look at it also as a heat map, which is very useful too. So these extra tools that I didn't even ask to be built into my app are there because the AI tool thinks that they might be useful for the kind of analysis that I would like to perform. And indeed they are. So just to wrap up with some takeaways from what I've learned doing this kind of exploration of Shiny Assistant, I found that it did have some limitations for more complex R packages, but it is very student friendly. And the type of scripts that it runs are easily editable if you learn a little bit more about R and RStudio and how to use it. And so the ease of using Shiny Assistant would really encourage me, and I hope my students, to get more familiar with our programming language. I think that this tool has a lot of collaborative potential, especially for developing different types of Shinies for teaching. And I will be doing more of that in the future.